So this is on classes and dynamic arrays. If you recall, when we create a dynamic array, we're actually using our free memory and we are storing whatever we dynamically create inside the free store, which means that the compiler will not automatically deallocate this memory, right? So if I was to create an integer pointer, p, as soon as I say p equals new int, then it goes and it will create a new space here for my integer. Right? If I say star p equals 1, for example, then we'll have p here, which is pointing to a memory address. Right? Let's say this memory address is 0002. So p's memory address would say is 0001. Now, if we say if p dynamically created this space, then this would be 1, which means that p is actually pointing here. So that means that p's value is going to be 002. Right? So we remember that from pointers. Now, we also remember that if we get to the end of our scope that we created this p pointer in, this int pointer, the integer will get deleted, but it will not delete the space in the memory. And so we actually have to manually do that by just simply saying delete p. And that will go ahead and wipe out this memory from this memory address. And therefore we can avoid a memory leak. So what does that have to do with classes? Well, remember in our last lesson, we had our date class, right? We had a date class. We did something like this: date D1, D2, and we passed the value for D2, and then I did date D3 is equal to D2. Now this is fine, right? Because if you recall, the class date only consists of private, right? We had private memory variables, and they were integers, right? We had month, day, and we had year. These are integers. So the compiler already knows how to make integers equal to each other. So saying something like this for a class like date, we don't really have to do much. We don't even really need to implement the assignment operator, right? We don't even really need to implement that because the compiler already knows how to set how to set an integer equal to another integer. And that's pretty much all this class requires when we use the assignment operator. But what about when we had our date operator? Not date, our dec class, right? When we had our dec class, we had a private memory variable that was called card, right? We had a deck of cards. Now, the compiler doesn't really, the compiler can guess, right? Because since our card class looks something like this, right? Our card class looks something like this, where we had int, rank, and suit. Right? And again, those are just integers, so of course it will know how to make those equal to each other as well. It can set an integer equal to another integer. It's totally fine with that. But we can run into problems when we're using pointers inside of our classes. So let's say we rewrote our dec class. Let's say that we wanted to make our dec class a little more dynamic, considering that not all card decks have 52 decks. Yes, your standard bicycle deck has 52, but what if you're using something like Uno or you're playing Goldfish? Those have a lot more cards, right? So what if we wanted to dynamically allocate our deck, considering taking consideration of different card decks that we could have, right? We might want to do something like this. We might want to make our deck a pointer. So instead of actually making it an array, we can just make it a card pointer, right? And we can call this deck still. But now it's a pointer, meaning that we will have to have some place where we will initialize this deck and dynamically allocate some space in the memory for this, right? And most of the time it would be inside maybe a constructor, right? Maybe we would have a constructor called deck, and then in our deck we will have the user pass the size of the deck, right? Our user can determine how big our deck is, right? And so then if we implement this, we would use our deck scope resolution, and we'll say deck int size. And inside here, we will pretty much just dynamically allocate, right? So since deck is a pointer, we would just say now deck equals new card, right? And then we'll say whatever size the deck is, right? And then we would probably want to go and start adding new cards, right? So we'll probably do a for loop, for int. And just for this purpose, I'm just going to say for int I equals 0, while I is less than size, I plus plus. And then inside there, we will just go ahead and add new cards to our deck. So I'll say deck I is equal to card. And so that's going to create 52 cards, whatever amount size the user gives us, it's going to create that inside our memory, right? So that's going to go ahead and dynamically allocate cards, depending on how many sides, we're going to have that many cards inside of our memory. So now, what happens if I wanted to go into my int main? If I go into my int main and then I decide I want to create two decks, right? So let's say I create a deck D1 and D2, right? And then let's say I want to say deck D3 is equal to D2, right? The compiler, if we don't overload our equals operator, what's going to happen is the compiler will automatically look at the deck class, right? And it'll see that we have a deck pointer, right? So it's going to do something like this. It will say D3 dot deck is equal to D2 dot deck. And what could be the problem with that? Well, if you haven't figured that out now, deck is a pointer, right? So if I set two pointers equal to each other, that means that they're both pointing to the same memory, right? So this is going to be my deck. This is going to be D1 dot deck. This would be we did D2 and D3. Let me just draw a new illustrations so this isn't too convoluted. All right, so when we created these two, we created a place in memory where deck is pointing, and this is for D1 dot deck. And then we created a place in memory where D2 dot deck is pointing. Now, if we say, if the compiler is going to automatically set the pointer for D3, right, the deck pointer for D3, if it's going to set it equal to the deck pointer for D2, then that means that D3 will be pointing here as well. Let me try to make that a little cleaner. D3 dot deck is pointing to the exact same place that D2, right? Because we know if we say pointer is equal to another pointer, it's just saying that they're pointing at the same thing. And so that's what's end up happening. So why is that a problem? Well, let's say somewhere down our code, I say deck2 dot clear deck, right? And this will just get rid of everything that's inside deck2. This will pretty much dynamically delete. It would deallocate all of the memory that deck2's pointer allocated. Well, if it does that, it deletes everything here, and so that means it also deletes deck3's deck because they're pointing to the same thing. So we actually don't want that to happen when we set something equal to each other if they're using pointers, right? If we're setting two classes that are equal to each other and that class has a pointer, we need to handle that, right? So what we need to do is we need to, if we're going to say equal, so if you can recall from our previous lesson, we have, we're overloading the equal operator. So let's just say we have our class deck, and deck has a private variable, has a private variable of type card pointer. We'll call it deck. Right, then if we want to make two decks equal to each other and we want to override the assignment operator, there's two ways we can do it. I'm going to do it the void way this way. So we say void, and then we have to use the operator. Remember, this is not a friend function. So we say void operator equals, and then we have our constant deck ampersand, and we'll call this deck. Right, so that is the way we would declare it. And so the way we would need to implement it is we'll say void, and since the assignment operator is a member function, we need to use the deck scope resolution operator. All right, and then we put our argument, which is going to be a deck reference. We'll call it deck. All right, and so if we want to make this class equal to the object that was passed to it, then right now all I have is this deck as my member variable. So naturally we would want to say something like this: the deck pointer that is part of my class is equal to the deck pointer that is passed through as an argument to my operator function. Except for this is no good for reasons I explained up here, because they will end up pointing to the same thing. And if you do anything to one, you're going to also do that to the other. So we don't want that. So what we really want to do is we want to get rid of this. We can't do it this way for the reason I just explained. So we have to create a loop, and we need to first we would need to if just in case our deck, right, that is part of this class, just in case it has any if it already allocated memory, right? If a deck already allocated memory, then we need to deallocate that memory first. There's no two T's. So if it allocated memory, we must deallocate first. Right, and so a way to do that is we just say if deck is not equal to the null pointer. Right, if it's not equal to null pointer, then we will delete deck. And since we know that deck is going to be used as a dynamic array, we must use the brackets, and so we'll say delete deck. All right, the next thing we want to do is we need to reallocate. We need to now reallocate memory for a deck for the new values that are going to come to our deck. So I want to say now deck equals new card, right? Because it's a card array. And then we'll say deck. We'll say deck dot get size, right? So this gives us the size of our deck, right? And of course, if we don't have this function, and actually we don't need to say get size. We actually don't want to say get size because get size is a function, and since we said that our argument is a constant, then the compiler is not going to let you call any functions unless you declare that function as constant as well, because it wants to make sure that whatever function you're calling from your object does not modify that object, because if it does, then it no longer holds the laws for constant, right? So let's just say size. Let's say we have a variable named size that keeps control of the size of our deck, which we should in our class. All right, so now we just created a new dynamic array that's the size of the deck array that was passed in as an argument. All right, the next thing that we want to do is now we want to copy everything from the deck that was passed to us into our deck. Right, so we just do a for loop. For int I equals 0. And right now I want to give the secret word, which is paper. The secret word is paper. All right. So int I equals 0 while I is less than deck dot size. Then we want to say I plus plus. Then we want to say that our deck, right? We want to copy everything from our deck. So remember this notation, star deck. Make that look a little bit more like deck. Star deck plus I is equal to star deck dot deck plus I, right? When I call deck dot deck, deck is actually the name of the object that I declared in my function, and then dot deck is actually getting the member variable, right? This is the member variable, which is a pointer. Right? This is my object. All right, so what I'm doing is I'm going to copy over what was in the deck from the object that was passed, and I'm gonna copy it over to my object. Right, so that's pretty much what I want to do, and that way now my deck deallocated new memory, so it's not pointing at the same thing deck 2 was pointing at, and then everything that deck 2 had is just copying it over, and that is the proper way to make those two objects equal. And then of course, if your object has a size variable, then you would have to say that your size is equal to what the deck size was. All right, so that is why if we have dynamically allocated variables inside our function, it's important that we implement our implement our assignment operators so that it doesn't point to the same thing that we're trying to copy points to, because that can be disastrous. All right, so that would be dynamic arrays in classes. Now, another thing that the book wants to talk about is destructors, right? So, so we have constructors, right, which will build our objects. If we're using dynamic memory, then we need to also write a destructor. And a destructor pretty much is a way for us to tell the computer, to tell the compiler how to delete our dynamic variables, right? So in my class, I have my deck, and if I have a private member named card deck, then I'm going to need a destructor so that I can tell the compiler how you should delete this particular variable in case there were something inside of that, in case this object had dynamically allocated memory to this variable, then I need to let the compiler know how to delete that. And so the way we write our constructor is similar to the way we write our destructor is similar to our constructor, except for we started with a tilde. So we use the tilde, and then we name it the same thing as our class, deck. All right, and notice there's no return value. It's just tilde and the name of the class. And that is our declaration for a destructor. Now, how do we declare our destructor? So this is part of our class. So we are going to need the class scope resolution operator. So we'll say deck, and then we'll say tilde deck. All right, and then in here we need to we need to deallocate any memory that was created. And so the first thing you want to do is you always want to check to make sure that that particular pointer is not equal to the null pointer, because if it's equal to the null pointer and you try to delete it, you're going to get an error. It's going to crash your program. So you want to say if deck is not equal to null pointer, then we want to go ahead and delete deck. And you're probably wondering, well, how come the compiler couldn't just automatically guess that? And it's a valid point, but there's a couple of things, right? So the card deck, right? The deck pointer simply says that it's a deck. It's a variable that is allowed to dynamically create variables of type card. But the compiler doesn't know whether dec did something like this, dec equals new card, or whether dec said something like this, dec equals new card. Right? It has no idea. And of course, if it did it this way, depending on the way we allocated memory, it really determines the way we deallocate it, right? With this one, we say delete delete dec. Where with this one, we say delete dec. So this is why the compiler can't automatically assume how to destroy our pointers, because it doesn't know how you allocated memory. And if this was a double pointer, then you would even do it in a different way. So what's the point of a constructor? Do we call this destructor? No, we do not. We never call the destructor. The compiler automatically calls the destructor. Now, when does it call the destructor? And before I discuss that, I want to talk about I want to talk about another thing, which is called a copy constructor. All right, and if you recall from previous C++ class, we have a function that are called pass by value, and we have functions that are called call by reference. All right, and so when we use a call by function, let's just say something like, let's say we had a function called int, max, and then we have int a and int b, and this pretty much just returns the maximum number between a and b, right? When we have this function and we pass some values, right? If we go into our int main and we pass some values, oops. Right, and if I pass this to my function and I say int y is equal to the max of x and x1, I'm only passing the value of x and x1 to my max function, right? So when I go into my max function, right, int max, int a, int b, this function actually creates new variables, int a and int b, right? It creates these new variables and it sets it to the values of x, right? And this one it'll create a new variable called b, and it'll set b equal to the value of x1, right? So in order for the compiler to do this, then it needs to know how to make a copy of an integer, which it does because an integer is a primitive data type. So it knows how to do this. But when you start making an abstract data type, it doesn't know how to make this copy in order for you to use your data type in a function. Right? So it needs to know how to do that. So with our copy constructor, right, a copy constructor is pretty much an overloaded constructor in a class that takes exactly one argument, and that argument is a constant of our class type. So if we had a dec and we wanted to make our copy constructor, it would look something like this. Dec, and then inside dec we'll have, needs to be a constant, dec. Right, that's the way we would declare our copy constructor. Now, our copy constructor is almost and usually always identical to our assignment operator. So we can implement our copy constructor exactly the way I showed here inside of our, right here. Uh, I can implement it the exact same way that I implemented it here, because pretty much when I do assignment, it is making a copy of the variable that's passed to it, which is a constant dec. And that's exactly the same thing that's happening with the copy constructor, right? We're passing a variable, a constant variable type dec into our constructor. So if we've already implemented our assignment operator, so let's say we have an assignment operator here, void, it's going to return, excuse me, this is an operator. Right, so let's say we've already implemented that. Then I could simply just go and make my copy constructor simply just call this operator, right? So I could say, here is the definition of my copy constructor. Right? And then I could just say, this equals dec, right? And if you remember what this is a pointer that is pointing to the object that we defined in our class. So this is an object, this is a pointer pointing to the object. So if I dereference it, that means that I'm actually talking about the actual object, which is pretty much me, right? It's pretty hard to explain, but this if this is an object pointing to myself, then when I dereference it, then I'm actually talking about myself, and so I'm making myself equal the dec. So that would be enough to make our copy constructor. So we could do it this way if we have the assignment operator already implemented, and then that requires us to do less implementation. So why did I talk about the copy constructor in the middle of talking about the destructor? And the reason why is because, like I said, if we need to use our class inside of a function and it's a pass by value, what happens when we get to the end of our pass by value function? Right? So if this was our function here, what happens when I get to the end of the function? When I get here, what happens? Well, what happens is that it deletes the variable, right? It deletes A and it deletes B, right? So if I have a object that dynamically allocates memory and then I delete it at the end of a function, what happens to all the memory, right? What happens to all the memory that that particular variable allocated? Well, what happens is it gets lost, right? We delete that variable and we don't do anything with the dynamically allocated memory, and so there's a memory leak there. So that's why we use the copy constructor, because as soon as the compiler decides to delete your class, it's going to call your destructor, and your destructor will then go and deallocate the memory that it created for that object. So that is the reason why you need a destructor, and that is the reason why I first mentioned the copy constructor. Now, notice that I also said that you have the equals operator, right? The equal operator does exactly what the copy constructor does. So there is actually a rule, and they call it the big three. There's the big three, which means that, and it pretty much states that if you need either a copy constructor or a destructor or an assignment operator, right? If you need any of these, then chances are you're going to need all of them. Right? Because the only time you really need to make a copy constructor is if the compiler doesn't know how to do it automatically. And that is usually when you have dynamic allocation, right? When you have pointers inside of your class as member variables. And so if you're dynamically allocating memory, then you are going to need the copy constructor so that the compiler knows how to copy that dynamically allocated memory into the new object, right? And then if the copy constructor is allocating memory, then it needs to know how to destruct it, right? And if you are using the copy constructor, then uh, that means that the compiler doesn't know how to make two objects equal, which means that you would have to write the code to let the compiler know how to do that. All right, so uh, that is dynamic variables in classes.